Hi all, welcome to the class. Today we are going to discuss a small topic in the fourth module of Mechanics of Machinery. Here we will discuss what is gear, type of gears and terminology of spur gear. First of all, we will discuss what is gear. Gears are normally used for precision machining or transfer of power from one shaft to another. Normally, the shape of gear will be round and it will be used where the driver shaft and driven shaft are very much close, or the distance between driver and follower is very small. You can see a figure of gear drive that comes. This is driver gear and this is follower gear. It's also known as driven gear. This is the front view and this one will be the top view. So you can see three circles. First one, the red one will be dedendum circle, blue one will be pitch circle, and outer circle will be addendum circle. This will be intersect with this one, and this will be a tooth shape. You can see the tooths are shown only here, but this will be continued in all directions, and you can even see the meeting of two gears here. This is the driver shaft till this one, and from here you can see a driven shaft. I think most of you know the gear mechanism. It is most commonly used in machines, mechanisms, etc. And now we will discuss why we are using gear drives. What are the advantages and disadvantages of gear drive? There are plenty of advantages and some disadvantages for gear drives. First one is it transmits exact velocity ratio. That is, it does not have any reduction or loss in speed. It may be used for transmit high or large power. Since this is a toothed mechanism, there will not be any loss of power, and you can even support high power in this drive mechanism compared to rope and belt mechanism. It has high efficiency and it is reliable service, and it compact layout. But these have two main disadvantages. Mainly, the manufacture of gears requires special tools and equipments. We know that the gear teeth are made by milling machine and lathe. These two are very important thing for producing gear tooths. And if there is any error in cutting teeth, may cause vibration and noise during the operation. These are the main disadvantages, and these noise and errors may cause damage of the teeth while continuous using. That's also a issue for gear drive. Now we will discuss what are the classification or type of gears. For that, first classification is according to the position of axis. How the shaft axis comes. There are three type of axis classification. First one is parallel shaft, intersecting shaft, and third one is non-intersecting, non-parallel shafts. So we will discuss one by one. In the first figure you can see parallel shaft. Parallel shaft means the axis of one shaft and other will be parallel. Here this is shows the two parallel axes, and for that we have four kinds of gears. First one is spur gear. You can see the teeth, all teeth are parallel to each other. And second one is helical gear. In helical gear, instead of parallel teeth, here there will be a inclined teeth. You can see the difference between spur gear and helical gear. One is parallel, second one is inclined. And third one is rack. Rack and pinion mechanism is used for transmitting parallel axis, and you can see an example of rack and pinion. Pinion and spur gears are commonly same shapes, or pinion normally known as the small gears used in a mechanism, and this will be the rack. This is rack and pinion mechanism. And internal gear. Internal gear is nothing but the gear will be in contact with the inside of the gear. This is the mechanism. And second classification is intersecting shaft. That is, the axis of one shaft will be intersect to another at a degree of 90. This is intersecting shaft. Even for 45 degree also there is 45 degree bevel gear is available. So there are mainly three type of gears. First one is meter gear or bevel gear, and second one is straight bevel gears, and spiral bevel gears. You can see the difference between teeth. Here teeth are almost straight, but here the teeth are curved. That is the difference between straight bevel gear and spiral bevel gear. And we have also another classification, that is non-parallel non-intersecting axis. That is, here the axis passing through x direction, and here that is passing through y direction. So it is not parallel shaft, and these two lines will never intersect any point. Here you can see this line and this line are intersecting at a specific point, but in this case these two lines will never intersect. So this kind of transmission is provided with the help of screw gear. That is, the teeth is, you can see here, teeth is in a special shape, curved shape, and another gear in this shape, that's also non-intersecting non-parallel type axis. And second one is worm and worm gear. This is another classification working in the same principle. Here it is a small example of a worm gear. This will be worm gear, and will be under receiver. And worm wheel, this will be intersect each other. These two are used for providing non-parallel non-intersecting axis. And now we will differentiate what are the classification of gears with respect to peripheral velocity. There are three classifications for gears considering the peripheral velocity, that is low velocity, medium velocity, and high velocity. Normally, if the velocity of the gear is less than 3 meters per second, the gears are known as low velocity or low speed gears. And if the velocity, peripheral velocity, is between 3 and 15, the velocity is known as medium velocity. And if the velocity is higher than 15 meters per second, the velocity is known as high velocity transmission. Now we will classify the gears according to the type of gearing, that is, whether the gears are external gears, internal gears, or rack and pinion. These are the main classification of gears according to gearing: external gears, internal gears, and rack and pinion. We can have a look about that. This is known as external gear. About 90% of gearing uses external gears. This will be driver gear, and this will be driven gear. When driver gear moves in anti-clockwise direction, the driven gear will be moves in clockwise direction. You can see the figure. This will be driver and this will be driven. So when this gear is rotating in anti-clockwise direction, this gear will be rotating in clockwise direction. All the parts are external comparing these two gears, so this is known as external gears. Now we will see what is the function of internal gears. Here the gear teeth is cut inside of the circle. Here teeth is cut at the periphery, and here this is cut at the inside. So for that an internal gearing, we are requiring an external gear and an internal gear. So this outside circle is known as internal gear, and inside circle will be similar to this one, that will be a small spur gear. So this gearing is known as internal gearing. And the main advantage is here the direction will be opposite to each other. Here driver will be anti-clockwise and driven will be clockwise. But in case of internal gears, if the driver rotates in anti-clockwise direction, the driven also will rotate in the same direction. That is the difference between external and internal gear. And now we will see what is rack and pinion. And for rack and pinion mechanism, the rack is provided at the bottom and the pinion is provided at the top. When pinion rotates, the rack will move in a reciprocating motion. That's the working of a rack and pinion mechanism. Here you can see a rack, and pinion will be in the same shape of this gear. This can be placed over this one, and when driven is rotating, the rack will be in a translation motion. This is the working of a rack and pinion mechanism. Now you will see some important gears. That is, first one is spur gear. When teeth are parallel to each other, you can see here the main difference between helical and spur gear are the shape of tooth. Here tooth is in straight line, here it is in a spiral case or inclined one. So this is spiral gear or helical gear, and this is spur gear. And we have already discussed rack and pinion, so rack will be in this shape, and another one is bevel gear. This is used for transferring power between two shafts that are not parallel, that are intersecting to each other. Here the teeth is in a special shape, and when this shaft rotates, that will rotate the driven shaft. This is the working of a bevel gear. And if the here the teeth are parallel, so straight, so this is known as straight bevel gear. And if the teeth are in a curved shape like this, here you can compare these two. These are in curved shape, these are known as spiral bevel gear. And we have another gear, that is screw gear. We have already discussed where these screw gears are used. Screw gears are used at the position where non-parallel and non-intersecting shafts are coming. And this is the small figure of screw gear. And meter gear, which have the same function of bevel gear, that's shown here. And worm and worm wheel are shown here. Here this one will be worm wheel, and this will be worm shaft. When worm wheel rotates, that will rotate the worm shaft. And these are also non-parallel, non-intersecting shafts. And internal gear we have already discussed. The teeth is cut inside of the material. There is a small example of gear mechanism. This is for our studies. When the bow is rotating, or sorry, not rotating, when bow is moving, the rack will be moved towards left and right. That will rotate the pinion, and this motion will be transferred to another screw gear through ratchet and prowl. The ratchet and prowl is provided for obstructing reverse motion. Okay, screw gear will be transfer power to worm wheel, and worm wheel will be transfer power to worm shaft. The worm shaft is provided like a internal gear mechanism to transfer. Here you can see an example of internal gear, how spur gear and internal cut gears are mating. This is the gear mate of internal gearing, and that will be transferred to a spur gear. Here you can see another type of gear, that is involute spline shaft with bushing. That is, this shaft will be cut like a gear. This is known as spline. If the entire shaft is cut like a gear, that is known as spline. And over that there is another gear, spur gear, provided with a bushing. This spur gear will transfer power here, and with the help of a meter gear, that will be transferred in 90 degree to another spline with spur gear, and the spur gear will transfer power to another helical gear. Here you can see the teeth shape that will be inclined to another spur gear, bevel gear, and finally to give the motion at the required position. This is an example. The bow is rotating this wheel, which is provided with a small rat. This is a small example of gear drive mechanism. Now we will discuss the terminology of spur gear or terms used in spur gear. You can see a figure. The main important thing is pitch circle, which is an imaginary circle, and according to this radius we are defining what is the dimension of a spur gear. And here you can see the distance between pitch circle and the top position addendum, and pitch circle and bottommost position as dedendum. And you can also see the top circle is known as addendum circle, and bottom circle is known as dedendum circle. Where is that? Here that is marked as dedendum circle, or it is also known as root circle. And The distance between addendum circle and root circle is known as total depth. And then clearance, you can see a clearance, that is the distance between root circle or dedendum circle and another circle is provided here for a small clearance for avoiding mating of top land of two gears, that is clearance, and this circle is known as clearance circle. And then circular pitch, in circular dimension in a pitch circle, the distance between same points, that you can see this is the first teeth and this is the second teeth, the distance between this point to this point or any point in a pitch circle of two consecutive teeth is known as circular pitch. And you can see the distance between these two parts is known as tooth space. This is tooth space in a pitch circle. And you can see the top part is known as face and bottom part is flank. Please read all the things, and top land, where these all things are coming should be memorized, because this is an important term and we are using this for upcoming problems. So study of these terms are very important in mechanics of machinery. We can see some terms. That one, first one is pitch circle. We have already mentioned that the diameter of a gear is specified according to the diameter of pitch circle, and it is an imaginary circle which is by pure rolling action would give same motion as actual gear. According to this only we are defining a gear, basic parameter of a gear. And pitch circle diameter, we have already mentioned that the diameter of pitch circle is known as pitch circle diameter. It is also known as pitch diameter, and the size of gear is usually specified in pitch circle diameter. Another one is pitch point. The common point between two mating gears is known as pitch point. When two gears are mating each other, there will be a common point of intersection, that is known as pitch point. This will be always in the pitch circle. And pitch surface, the surface of rolling disc which meshing gear have replaced at the pitch circle. You can see the pitch surface. This is pitch surface element, that is this line will be the pitch surface element. And another one is pressure angle. This is a very important term. For every gears, normally gears are standardized and normally used pressure angles are 14.5 or 20 degree. This is an important term. For every gears we are using two pressure angles. One is 14.5 and 20 degree, and this is experimentally proved that this is the best or optimum pressure angle for gear transmission. And it is the angle between common normal to two gears at the point of contact and the common tangent at the pitch point. This is the definition for pressure angle. And now we will discuss what is addendum. We have already mentioned that the pitch circle, the distance between top land and pitch circle is known as addendum, and pitch circle and bottom land, that is root land, is known as dedendum. The circle or outermost circle is known as addendum circle, and bottommost circle is known as dedendum circle. These are also known as, this dedendum circle is also known as root circle. And now we will discuss what is circular pitch. It is an important term while designing a gear mechanism. It is the distance measured on the circumference of pitch circle from a point of one tooth to corresponding point of another tooth or next tooth. It is usually denoted by PC. We have already shown this one. I can show you. Circular pitch is shown here, the distance between this point and this point. Similar points in a pitch circle, curving pitch circle, is known as circular pitch. And there is an equation for PC or circular pitch. PC equal to pi d by t. This is the equation, and where d is the diameter of pitch circle and t is the number of teeth on wheel. And another thing is pitch circle or circular pitch is common for both teeth if they are in encased position. So you can write the equation as pi d1 by t1 is equal to pi d2 by t2, and from that we have a driving equation d1 by d2 equal to t1 by t2. This is an important term. We must be memorize this one for further calculations. And it is another pitch, diametral pitch, or it can be expressed as the relation between number of teeth to pitch circle diameter, normally expressed in mm. You can see the equation T by D, where T is the number of teeth on wheel or pinion and D is the diameter of pitch circle. And module, it is the opposite of diametral pitch, or it can be expressed as M is equal to 1 by PD, and it can be expressed as the ratio of pitch circle diameter in mm to the number of teeth. It is normally denoted by M, and normally modules are standardized values. And clearance, we have already mentioned the radial distance between top of the tooth to the bottom of the tooth in a meshing gear. We have already shown the figure, and where there is a meshing gear clearance circle also mentioned in the respective figure. Total depth is the sum of addendum and dedendum, and working depth is the distance between clearance circle and addendum circle. And tooth thickness, it is the width of tooth measured along the pitch circle. We have already shown in the figure what is tooth thickness. If anyone have query, you can go to that figure and understand what is tooth thickness and tooth space. These are very important terms. And another important term is backlash. Backlash is nothing but the difference between tooth space and tooth thickness. Normally in theoretical case, the teeth are in contact at the engagement and disengagement points, that is there will not be any backlash, but in actual case there will be a small backlash provided for avoiding jam and errors due to thermal expansion of teeth. Since the gear material having thermal coefficient, there may be chance to expand or reduce the shape of gear when that is in continuous motion or in thermal conditions. So backlash is an important thing. If the backlash is high, there is a chance of slipping of gears between each other, and that will cause reduction in efficiency of the transmission. So backlash is a mandatory thing, but the excessive backlash may cause failure of gear transmission mechanism. And face of tooth, it is the surface of gear tooth above the pitch surface. We have marked it in the previous figure as face and flank. And topland is the topmost surface of the gear, and face width is the that can be expressed as width of gear tooth measured parallel to axis. And another one is profile, gear profile. This is the complete profile coming from face and flank, that is shown here. This is the gear profile, start from this point to this direction and coming to this shape. This complete shape is known as profile. And you can see in previous one I have mentioned face width, that is this distance is known as face width. And fillet radius, it is provided at the root surface to avoid the interference, that is fillet radius. And another one is path of contact. It is the path traced by point of contact of two teeth from beginning to the end of engagement is known as path of contact. And length of path of contact can be expressed as the length of normal cut off by addendum circle of wheel and pinion. And arc of contact is traced by the path traced by a point on pitch circle from beginning and end of engagement of a given pair of teeth. The arc of contact consists of two parts. And these two things, length of path of contacts and arc of path of contacts, are very important in our next classes, and we will find the equation for finding length of path of contact and arc of path of contact. And on those conditions, I will explain what is these points and arc of approach and arc of recess. This is the splitting of arc of contact in can be arc of approach and arc of recess. Arc of approach is the portion of path of contact from beginning of the engagement to pitch point, and recess is the portion of path of contact from pitch point to end of the engagement of pair of teeth. These are very important, and today I am winding up the class. If you have any queries, you can ask by mailing me. Thank you.